Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. Today, we're going to be talking about smart irrigation for agriculture, and more importantly, how this helps with carbon capture. Now, for a lot of people, including myself, these are two subjects that you don't normally hear together. But after I talked to Jim Loria, our guest today, I certainly see how it works and how we do put these things together, and how many gains we can make concerning carbon capture, focusing on ag irrigation. Now, I'm not going to steal Jim's thunder, that's for sure, but I do want to tell you that I know if you've seen him on here before for our webinars, you know what a great presenter he is. He's the Vice President of Sales and Marketing at Maisie Injector Company. He's a leader in the water treatment field. He's written books. He writes very regularly about water conservation and water management. He has a podcast that if you haven't heard yet, after you're done today, search for him on the podcast. It's very entertaining. Thing I really appreciate about Jim is for most people, water management and water conservation isn't very interesting. Jim's one of these guys who has figured out how to make it interesting, and he's with us today, and I'm really excited about that, to talk about carbon capture and water. So Jim, welcome, and thanks for joining us today.
Thanks, Richard. It's always a pleasure. I appreciate the kind words to introduce me.
Yeah, you bet. Well, you earned them. So Jim, you know, one of the things, you know, I think we need to start with right away and help us out with is what in the world is carbon capture?
Well, I mean, first of all, you got to talk about CO2 and its greenhouse capabilities. And it's probably the largest greenhouse gas. And we'll talk about some other ones later on in the presentation. But what happens is CO2 absorbs and emits infrared radiation, trapping heat and warming the Earth's surface and atmosphere. And we're not going to get into the whole idea of climate change, but CO2 is a whole aspect of transportation, energy generation. You're releasing CO2 and it gets into the atmosphere and it can cause some issues.
Yeah. Okay. So it's the actual release and the damage it does, right, to the atmosphere. That is the real concern.
Exactly. Exactly. So what happened a little while ago, back in April, Lawrence Livermore Labs gave a presentation at Cal State Bakersfield about where they thought it should go as far as capturing carbon. And Angelo Maisie got a copy of this Getting to Neutral that was a report that was presented. And he knows I'm a big science geek, and he sent it to me, and I read it cover to cover, 178 pages. And they had a number of different ways that they felt they could get to neutral by capturing carbon. And they talked about cover crops. They talked about biochar, pyrolysis of different ways of getting this, capturing this carbon. They actually talked about capturing carbon from the atmosphere, pulling it in with equipment. And one of the things I didn't see was how agriculture could be involved. And so, you know how I am. I wrote an opinion piece for the Bakersfield Californian about including California farmers as a key to carbon capture. I felt that, look, if you're talking about carbon capture, one of the best ways to do it is to pull it into crops for food, fiber, fuel, into the soil, capture it that way. And I ended up giving this presentation to Cal State Bakersfield a few weeks ago about this whole idea that if the solutions to carbon capture neutrality, they're all going to require water. Why not give the water to the farmers to capture the carbon, just as I said, for food, fiber, and fuel?
Yeah, so I want to stop you right there and
Sure.
remind everybody we have the chat and the Q&A open. So if you have a comment or you have a question for Jim you'd like me to ask him, type them in there. We've been given some great swag from Jane for the people who ask good questions. So you get an opportunity to have a t-shirt or hat sent to you with the Irrigation Training Series Academy t-shirts. But here's the question that's coming in already, Jim, and that is there much carbon to capture in agriculture? Does agriculture contribute to a lot of carbon emissions?
Well, we'll talk about that going further. Yeah, absolutely, because there's the tractors that are used to plow the fields. There's the transportation of the food to the urban centers, which we'll address later on in the presentation. So yeah, absolutely. And we'll talk about not only CO2, but some of the other greenhouse gases that agriculture contributes to. But the point is, we as in the agricultural industry, if we're going to be able to use that water to capture carbon, we're going to have to use ag tech. And it's a big discussion around, you're talking about satellite imaging, drones, robotic tractors to improve yield, efficiency, profitability, and in terms of carbon capture, sustainability. But what I like to say is smart irrigation is a really important portion of ag tech, a subset. It's kind of where the rubber meets the road, right? You've got the water and you've got the fertilizer right at the soil, right at the plant. And so it's an important way of using smart irrigation to improve this efficiency of all the inputs, water, fertilizer, nutrients there. So precision agriculture, we use that word a lot, equals distribution uniformity. And not only in terms of water distribution uniformity, but again, in terms of fertilizer, nutrients, how that is distributed in the soil to the plant level. So here's a little graph that I show about the growth of subsurface drip irrigation in California. And I can't tell you why we've only got to 2010, but you can see compared to gravity and sprinkler, it's really grown. And it's really important to show this because in terms of drip irrigation compared to sprinkler and flood, numerous studies have shown that drip irrigation reduces carbon emissions, it increases yields, and it reduces the use of fertilizer. So the growth of drip irrigation is really an important factor in smart irrigation, improving all these. And we're going to talk about the idea of fertilizer and yield improvement.
Yeah, so Jim, I'm sorry, can we go back one slide?
Yeah, sure.
To say, if I'm reading this slide correctly, gravity or flood irrigation in this case is still, in 2010, it was more than 40% of the ag water use was flood irrigation. Now I know it's lower than that, a little bit lower than that today, but this is still something that growers are using, apparently a lot of.
Right. And that's why we're really promoting, and this is in California, so we're, which is pretty ahead of the curve, right? I mean, so we're really, as far as a country and as far as the world, I think we're still way behind where we should be in terms of, as I said here, the ability to reduce carbon emissions, to increase yields, and to reduce the use of fertilizer, right?
Yeah. So I think you got me going here now. So I think that flood irrigation is probably one of the most wasteful ways to irrigate. And we talked about urban water and getting people not to water their lawns, right? And here in San Diego, they'll pay me $4 a square foot to take out my lawn. So about $170,000 an acre to remove my lawn. I think we should be looking at some government subsidies or some government help or incentives, right, to take out the flood and put in drip at $1,500 an acre and move some of that $170,000 an acre to remove turf in San Diego to some urban applications where we're going to end up saving a whole lot more water for a whole lot less incentive.
Right. So, I mean, we talked about this. 70% of water use is for agricultural applications, 20% for industry, and 10% just for, the general public, right? Drinking water, lawns, things like that. So, I mean, it's a small percentage what you're talking about as far as landscape, and a big percentage for the crops we're growing for food, fiber, and fuel. Right?
Yeah. So, all right. Thank you. I'll let you get back to presenting, and I'll ask.
No worries. Anytime. Just stop me, and we'll talk about it. So one of the trends I'm going to talk about, some trends in the industry, is automatic fertigation. This is a rendering of a system that Maisie's involved with. There's a lot of these out there. A lot of them use different types of ways to put the irrigation, the fertilizers and nutrients in. Many of them are incorporating Venturi injectors, and most of those are Maisie injectors. And we're working with a lot of different partners. I know a couple of months ago, John Petroso and Connor Cunningham talked about the collaboration between Jane and Maisie to be doing exactly that, automating, using data to capture information that can be better used to do the right thing in terms of fertigation, fertilizer, nutrient addition. So this is trends that are going to help this idea of smart irrigation that we're really proud of.
Yeah. Yeah, Jim, I think that's great, right? That you guys are really on the cutting edge of this. And I think it's, I'm sure it's reflected in the amount of customers and the numbers that you guys are selling right now. And I think back, 30, 40, 50 years ago, it just wasn't necessary. It's not that anybody is trying to abuse the system or be wasteful. It just wasn't necessary. But now with the amount of food that we have to supply, it is becoming necessary to really manage these resources a lot more carefully than we have in the past.
Right, and we aspire to the 4 R's of nutrient stewardship. I mean, this was kind of developed by Dr. Charles Bird of Cal Poly, and he's written a book on fertigation. So you want to have the right source, the balanced supply of the essential nutrients, the right rate based on the soil nutrient supply and the plant demand, the right time, when during that time, based on the dynamics of crop uptake, soil supply, and field operation logistics, and then the right place and address root soil dynamics and nutrient movement through the soil. And I know Corey Broad, he gave a really good presentation a little while back about the movement of nutrients and water through the root zone to the root zone. Quite interesting things that he was doing to improve that. So really we're looking at that as smart irrigation addresses all these different issues, right?
Yeah. Well, thanks for bringing those 2 webinars up, Connor and Corey, and John. Boy, they've all done a great job.
Yeah. So this is a trend in nitrogen fertilizer in California from 1945 to 2008. And you can see the steady increase, and it's going up. And, the ideas around nitrogen fertilizer, if you really want to put it, only for the amount the plant needs, that's an important part of smart irrigation, just to apply it, and potential of not having it there and for useful purposes is a real problem. And we'll show that in a few minutes, right? So reduce fertilizer use. So we know, given the global issues right now, Ukraine, some of the other things happening, there's low production rates of fertilizer. The production of fertilizer is using natural gas, which obviously when you produce something with natural gas, there's a carbon release that we talked about, CO2 release. And then we'll get into the idea of oversupply of fertilizer results in some issues around watershed. And you really want to protect watersheds. So here's some of the problematic issues around overuse of nitrogen fertilizers and any fertilizer for that matter. So we've heard, and there's been a lot of reports about blue baby syndrome in the Central Valley, where the nitrates get into the groundwater, can cause real problems. Then you've got the issue of phosphorus getting into receiving bodies. And this is showing some algal blooms. And one of the big issues we saw just recently in the city of Toledo, they almost shut down their water supply, their drinking water supply, because they were getting these algal blooms that were producing cyanotoxins, which are very dangerous to humans. And Maisie was very much involved in that. And we were involved in the design of the water treatment system and ozone system that was actually going to break down our cyanotoxins and make sure that the drinking water supply in Toledo was safe. And this is a rendering on the bottom right there of what our design system looks like. And what you can see is there's a lot of concrete there and a lot of stainless steel. Well, the two biggest producers of carbon dioxide is in the production of concrete and in carbon in steel. And so if you've got to mitigate something around the problems of nutrients getting into receiving bodies, then you're just increasing the amount of greenhouse gases that are going into the atmosphere because you're trying to address these problems upstream. So it's an interesting case. I mean, one of the things I was thinking about when I show this is you're old enough to remember that Fram Auto, the Fram Auto filter, right? You can pay me now or pay me later. So if you don't do the smart irrigation side of things, you can pay me now, or if not, you can pay me later in terms of having to mitigate these things further on down the line.
Yeah, great point there, Jim. We've got a question that's coming in, and somebody's wondering, how do you actually measure carbon captured in agriculture?
Well, it's kind of difficult. I mean, you're going to have to measure how much yield improvement you're going to get from all the different systems you put in. That's one of the ways, but to specifically, I mean, there's a lot of details in trying to say specifically, this is the amount of carbon you've captured by improving the systems involved in improving the technologies around it. So quite complex. I mean,
yeah, but
it's people. I mean, this whole company's devoted to this kind of thing, right? And much smarter people than me are doing that kind of work.
Right, certainly an opportunity there. And then, can you monetize it all, the carbon capture? Is anybody monetizing this in any way?
Oh, absolutely. I mean, there's a lot of people looking at how you capture it with equipment. There's people doing trading of carbon credits, right? Growing trees somewhere and saying, okay, you're releasing this much carbon dioxide and you're growing this many trees. So there's numerous companies that are doing this carbon trading, and it's very, very complex. One of the examples I always use is, so if you clear cut some Amazon rainforest and grow soybeans, is that a good way to capture carbon in agriculture? And I'm sure that there's people who say, absolutely not, doesn't make sense, right? So again, it's very complex. But one of the things I want to talk about is I was on a webinar a few months ago, and the chief sustainability offices at Anheuser-Busch InBev and PepsiCo were on the call. And so I asked the question, what were they doing in terms of pushing their upstream supply chain, the farms that were providing their inputs for their products? Because if you look at beer, right, that's water and it's some kind of grain, barley, corn, rice, and hops. And then if you look at Pepsi-Cola, what's that? That's water, and that's some kind of sweetener, corn sweetener, beet sugar, cane sugar. And then all these other companies, these are some of the biggest corporations in the world, and they're really the ones that have to look at, how are they managing their partners, their supply chain partners, to do a better job of improving the way they're growing their crops for inputs into their products.
Yeah, I think you're totally right there. And, we don't have reporting of water use qualifications or laws for any of these companies, but the ones that are actually making this information available, I think, are going to win more consumers as a result. And I really think, especially in the newer, younger consumers, this stuff matters to them. I think they'll pay more for a product if it is managed correctly. I was in a restaurant a while back and I saw that the French fries were grown with potatoes from Pocatello, Idaho. And I thought, wouldn't it be great if they could just take it to the next step and, at which were watered by drip irrigation, the most efficient irrigation available today.
Yeah.
But you can see it's going this way. It's very exciting.
Yeah, and my question is, and you and I have been around for a while. We've been at the IA show, the World Ag Show. I've never seen any representatives from these companies really trying to find out, the best technologies to push down the supply chain to their partners. And so I think it's incumbent upon them to really understand what smart irrigation is, how best to do regenerative farming and things like that. So, I think it works both ways. We got to do a better job as an industry to impart our ideas, our technologies, the future of how we see it. And it's, incumbent upon them to also learn about what's going on, cutting edge technologies that can improve how we use water and nutrients in the agricultural space.
So we've got another question coming in, Jim, and it's around regulation. And do you have any information on government regulations, California or federal level, that will enforce or push consumers to reduce their carbon or their fertilizer or the other things that contribute to carbon emissions?
I haven't seen any. Really not. I don't know, maybe I missed some things, but I don't see regulations saying you can only put this much fertilizer on a field, or I'm sure that if you see nitrates in the groundwater, they'll find out, well, who was putting these nitrates in, who was responsible for the phosphorus going into Lake Erie that created this problem. But again, it's complex, right? Was it phosphorus coming from farms? Was it phosphorus coming from wastewater treatment plants that were releasing their sewage that wasn't being properly treated? So it's we're talking about a very complex issue.
Yeah, exactly. And so what I'm excited about is if they don't have the laws now, they may be coming, but we as an industry have an opportunity to take control of the situation, an industry that we know more about than any legislators. And so we have the opportunity to do the right thing now and eliminate having somebody come in with a lot less knowledge, put restrictions on. So I look at this as a huge opportunity.
Right. So another area that we have to talk about is that we're talking a bit about it is nitrogen, right? And we talk about CO2, but nitrogen in some regards is a bigger problem. We talked about nitrates in the groundwater, but also nitrous oxide, ammonia, nitric oxide leaving from the plants and the soil. This is a graph that kind of an image that I got during a presentation that Dr. Dave Guruhu of Fresno State and I put together a little while back. And this is an interesting slide from the EPA on nitrous oxide emissions by source. So you can see agricultural soil management, 3/4 of it is coming from the agricultural community. And then the second biggest one is wastewater treatment. Yeah. So most of it is happening either through the agricultural application or through wastewater treatment. And here's another study that was done by UC Davis, which says that the nitrous oxide is even more than they think it was. They did an initial study and they found out it's about 40% of the NOx emissions in California is from Davis, a fertilized soil in Central Valley region. And to put that totally in perspective and a little bit of humor, at 300 times the greenhouse effect of CO2, which I looked that up, it's true, nitrous oxide is no laughing matter. This comes from my good friend and comedian, Steve Behrman. And everybody knows nitrous oxide is laughing gas. We talked a little bit about it before the presentation, but it's a very powerful greenhouse gas. And a couple of things. So CO2 is picked up by plants, right, during the photosynthesis process, but nitrous oxide sticks around a lot longer. And so it's only about 7% of the total amount of greenhouse gas emissions compared to CO2. And then number 2 is methane. We won't get into that. But because it's 300 times the greenhouse effect, it does create a lot of problems.
Yeah, no, I love this. I love this saying there, or that comment. I saw it on your LinkedIn profile too, and that was great.
Yeah. So one of the ways we're addressing this, again, talking about smart irrigation, is oxygenation, and we'll talk a little bit about that. So over 80 years ago, W.D. Durrell said a study of suitable oxygen carriers which could be applied as fertilizer and which would release oxygen slowly to the soil during the growing season may be worthwhile. And so there's a couple of ways of adding oxygen, air to the soil. So there's a ventilation compressor, just putting air into the soil. And it's not a very effective way, moves away from the root zone. There's no real proper way to control the air. You could use chemicals, you can use hydrogen peroxide, but it's a very strong oxidant. You got to handle it. And also you got to be careful. If you put too high a concentration in there, you can destroy some of the beneficial microbes in the soil that help with the growth of the plant. Nanobubbles generating system. I'm not going to talk too much about it. Frank Tovas did a good job talking about nanobubbles. You wrote an excellent blog just recently about nanobubbles and generating the benefits of them. And then there's what Maisie's been talking about for a number of years called adjection, on how we're looking at it. And for adjection, basically you're taking air through a venturi and you're creating micro bubbles and you're putting dissolved oxygen. And what that does is two things. The dissolved oxygen helps those microbes and creates a better aerobic environment to help with the plant growth and the actual uptake of nutrients. And also the micro bubbles actually break up the soil. And we like to call that plowing without a plow. And it's chemical free. There's really no moving parts. All you're doing is with the motive force of the water through the injector, through the venturi injector, you're pulling in air and creating this turbulence to mix in the dissolved oxygen and also the bubbles to help break up that soil.
Yeah, I love that, plow without a plow, without disrupting the soil or any of the microorganisms in the soil. You're still adding oxygen. It's great.
Right, and we did some really good research, and in conjunction again with Dr. Dave Gurhu of Fresno State and Dr. Adrian Unk out of Memorial University in Newfoundland. And what we found was there was some changes in the type of microbes that are in the soil by using adjection. And you were getting more aerobic activity. And what that did was you were able to reduce the amount of nitrous oxide in NOx compounds. You were actually capturing more of the nitrogen to the plant and less being released into the atmosphere, which is a big benefit, not only in terms of yield, but also in terms of keeping that nitrous oxide and other NOx compounds from getting into the atmosphere.
Yeah, I love it, right? This is what we're talking about, using technology to solve these water and carbon issues, not just telling people don't do it.
Exactly. And then the other trends in smart irrigation I want to talk about is controlled environment agriculture. And this is a growing trend. And one of the things you and I talked about is obviously you're trying to feed people where they're at. And you know, I'm a big fan. I have arugula every single day. For me, a day without arugula is a day without sunshine. And so yesterday I had an arugula salad for lunch, and it was grown only a couple of miles away from my house in a controlled environment setting, just down in South San Francisco at the Plenty Vertical Farm. And this is a growing trend, but you know, again, it's about technology. It's about smart irrigation technology. And ultimately, you know, the way I feel about it is any crops that can be grown inside should be. And if you grow crops close to urban centers, that means less transportation that's going to be required to bring them to the people where they're being consumed. And so you're talking about less CO2 in terms of diesel and trucks moving this produce. So that's another way you can look at it. And right now, crops that are being grown there, tomatoes, leafy greens, like I said, arugula, lettuce, a lot of other leafy greens, and then strawberries. And then one of the biggest cash crops, the biggest cash crops in California is cannabis. And so I know you guys have done a lot of work on cannabis, indoor growing of cannabis. So, but the idea is that if you're going to do this, you're going to have to manage that water. And again, it comes down to smart irrigation because the water delivers nutrients and other inputs, and it's a major cost. You got to manage that water, but you got to make sure that you're treating that water either before it's being released, or more importantly, as it's being recycled. And here's a little diagram of a vertical farm system. We have a partnership with H2O Engineering. They're using our equipment, our Venturi injectors, some of our pipeline nozzle manifolds to put ozone in, because one of the big issues is the idea about biofilm, because biofilm can really harbor pathogens that are going to be a problem for the roots, for the growth, for the yields. So if you're going to recycle that water, you better make sure that you have adequate filtration and you do something to destroy that biofilm and any pathogens that might be in that water. And ozone is a really good disinfectant, a really good sanitizer for exactly this application. And so I put together, I always like to see which of the corporations are involved. So we talked about Plenty. That's where I get my arugula from. Bowery Farms is one of our customers. Gotham Greens, Aero Farms. So I like to follow the money, right? So Plenty, if you look at Wall Street private equity firms invested, Jeff Bezos. So a lot of these products are sold through Whole Foods, which is owned by Amazon. And then Walmart just invested $400 million into Plenty.
Wow.
Bowery Farms, the big investor is KKR, Kohlberg, Kravis, Roberts, the old leverage buyout guys. And, but some interesting celebrities, right? Lewis Hamilton, the race car driver, Justin Timberlake, the pop star, Natalie Portman, the actress. Gotham Greens is a Colorado private equity firm, Manitree. And then Aero Farms is ADIO, and that stands for Abu Dhabi Investment Organization. And it makes sense. I mean, if the Middle East countries are looking at being able to supply their people with food and food security, not worrying about bringing it in from other places, they have little arable land and they have very little water. So they're looking at this kind of technology to make sure that they're producing their food for their people, for their population locally. And we talked a little bit about this, but we really think it's incumbent upon the trade organizations in our industry to promote it. And I know, I'm on the board of directors at the CAIA, and we're doing a big push. We're talking about this at our upcoming Pismo Beach meeting coming in September. The IA is important. And then the International Ozone Association, we just did a presentation similar to what I talked about on ozone for vertical farms and horticulture. So we really need to get the word out and become advocates for smart irrigation through these trade associations.
Yes, so Jim, your CAIA conference in Pismo Beach here in September, which is going to be here in a blink of an eye.
Yeah.
You guys are going to do some farm tours this year?
Yeah, we're going to do a strawberry tour. And then, of course, we always have to visit a winery.
Yeah. All right.
And do
They're always...
and do some tasting, right?
Yeah, yeah. Well, it's always great to visit the places that are actually progressive, and I learned so much from seeing somebody do it, and being able to actually ask questions of somebody who's done it. So that's great.
Yeah, yeah. Last year, Cassie Tovis organized a tour of a strawberry farm using substrate. It was very fascinating, and I like to tell the story that I walked into they had a facility there, a container consisting of all their water treatment equipment, and I thought I was walking into a municipal water treatment facility.
Huh.
It was pretty amazing.
Yeah.
And that's one of the areas, we at Maisie live, and to see the level of technology, SCADA systems doing all the control was quite fascinating to actually see this being used in an agricultural application. So,
yeah, that's great to see it firsthand. You can't learn that information from a book.
No. And then just Maisie's commitment to smart irrigation. Angelo started the company based on that back in the 70s. And he saw the fact that there was a better way to add fertilizer nutrients when the central irrigation project came on board, and he felt that Venturi injection would be the way. And that's where the company started. And we've grown from there over 40 years, 20 US patents. And, it's great to see him recognized with the Irrigation Association 2021 Industry Achievement Award. I mean, he's been receiving awards for many, many years. He received from the Association of Agricultural Engineers and Biological Engineers back in 2002 for the work he did on ejection and how that was changing things in the irrigation situation. And then one of the things, and I alluded to it, is that Maisie's involved in a lot of applications. After Angelo starting the company around irrigation, we've moved into areas like municipal water treatment, industrial water treatment. And because of that, we've had to become more sophisticated in how we're using modeling. So we have a PhD on staff in computational fluid dynamic modeling. And we do a lot of work around that to make sure that our designs are working for our municipal industrial customers. And what that's done is led us to use that kind of information and ideas to better enhance what we're doing in the agricultural field. So with ejection, we're working on improving our systems using this computational fluid dynamic modeling that we've used for many years in the municipal industrial space. And so I'm going to finish up. One of the things I like to talk about is the circularity of water, right? So we talked about 70% of water is being used for irrigation. So it's important that we look at how that is affected, how we talked about the runoff with phosphorus, nitrogen, the problems that can cause for source water. And, Maisie's works on the margins of all these different applications. So the source water, what is that? That's feeding our drinking water and commercial water for the different applications we talked about, right? And then you've got the wastewater that comes out of that and water reuse. So if irrigation is using 70% of the water, that means that most of the water reuse should be going to irrigation, right? I mean, it just makes sense. So it's important to look at all this interconnectedness of the water systems that we're involved with. And one of the things we're proud of at Maisie is we like to be able to tell the story of how this is connected, because we are in all these spaces. So we like to get the people involved that we talk to in agriculture to know more about what's going on in municipal and industrial space. And the same thing, we talk about the people when we're talking about Water Online, which is one of our big partners or platforms for the municipal industrial space. We like to bring in the ideas about what's going on in the agricultural industry. So it's been our way of kind of being involved in all of this to promote this. And last slide. I want to talk about an initiative, a campaign. July is Smart Irrigation Month, And I have a podcast with my partner, Adam Tank. What are we talking about? That's on the platform. And as I said, we brought in some experts in the agricultural market to talk about it. And so every week this month, I've been putting out these smart irrigation voices. We had Cassie last week, her interview on LinkedIn. This week was Dan Keppen. Next week's going to be John Farner. And then, you and I are big baseball fans. So I figured that I'd have my power hitter batting cleanup, and you're going to be at the last week of the month. So anyway, it's a way for us to get the word out to people that, and some really good insights from all these different smart irrigation voices that we wanted to promote. So appreciate it.
Absolutely. I'm so honored to be on this slide with some really great people. And you and Adam do a great job on your podcasts. I really have enjoyed those, and again, made water interesting.
Yeah, great. So that's the end of my presentation. Any questions? As always, connect with me on LinkedIn. If you're not already connected with me, you can get to me, jlaurie@mazie.net. Check out our website, mazie.net, and be happy to take any further questions that we haven't addressed yet.
Yeah. So Jim, I want to say thank you for joining us today. Really appreciate it. And then thanks to all the great work you guys are doing at Mazie. You guys have been leaders in doing this a long time. Glad you mentioned Angelo and the great work he's done, and the recognition he's gotten of that recently is well-deserved. So thanks for bringing that up. I want to say thank you to all our viewers. We appreciate you taking some of your day and spending it with us to learn about water conservation, sustainability, and how we be better water managers going forward. Remember, you can see all our trainings, almost 200 now, at the janesusa.com website. Just, go there, search trainings, or click on the tab, or /trainings will get you there, or wherever you listen to your favorite podcast. We're getting tons of podcast downloads on a monthly basis. And I love to think that people are out there working in irrigation, working as a grower, working as a landscaper, and at the same time improving their skills. It's very inspirational to me, and keeps us all going. So we appreciate that. Jim, again, thanks very much. Great job today. Learned a ton as usual, and we'll keep on pushing this Smart Irrigation Month message along all month long. So thank you.
Absolutely. Thank you.
Okay. Thanks, everybody. We'll see you guys next week.